Hello students, welcome to the video lectures of software engineering. So today we are going to talk about control structure testing basically. Okay, so what is control structure testing? And so there are a couple of things under this control structure testing which we are going to discuss. So basically this control structure testing focuses or it broadens the testing coverage and improve the quality of our white box testing. Okay, so just let me write the point here. So it broadens testing coverage and improve quality of white box testing. Okay. So now basically this in this particular control structure testing, it introduces you a group of white box testing techniques that test different logical control structures in the code. Okay. This will test different logical control structures in code. Fine. So now, so basically, these testing techniques will focus on how the logic flows inside a program. Okay. Inside a program, when I say it is all about the conditions or loops or branches and even sometimes how the variables are defined and used. Okay. So in this, there is a condition testing which we'll talk about right now. So condition testing. So this is a test case design method that exercise the logical conditions contained in a program module. So a simple condition is a Boolean variable or a relational expression, possibly preceded with one not operator. Okay. So now in a white box test design technique, which exercises all the logical conditions in a program. So now we discuss about this condition testing, where a Boolean expression is like, as it is mentioned here, a Boolean expression is like, let's say A is greater than B. Okay. X is equal to 0, like this. Okay. So like there are two things like simple condition and compound condition. Simple condition is like one Boolean or relational expression we say. Compound condition is multiple conditions joined with and or. Okay. So then what is the objective of this? So the objective of this particular is to check each condition is true or false outcome to ensure that the all branches of logic are tested. Okay. So next we have data flow testing. So the now this data flow testing will test the program by checking, how the variables are defined and used inside the code. So that's what it's saying. The data flow testing method selects test paths of a program according to the locations of definitions and uses of variables in program. Okay. Okay. So now let us see by an example. Now, if you see this, it is mentioned over here. So definition of yes, this is set of, sorry, let me write here. Def of S is set of variables. Okay. So that is defined in statement yes. So when I say use of yes, that is here. This is def of s, and then this is use of s. Okay. So this is defined, this is use. Okay. When I say this use of s, which means set of variables used in statement yes. So this is what it's saying. So if statement yes is for if or loop statement, its defined set is empty and its use set is based on the condition of statement yes. So the definition of variable x at statement yes is said to be live at statement s. If there exists a path from statement yes to the statement s dash that contains no other definition of x. Okay. So now for example, let us say int x is equal to 5. Okay. Now, let us say this is your def of x. Okay. Then y is equal to x plus 1. Okay. What is this? This is the use of x. No. Got it. So this is what data flow testing does. Clear? Now, if you observe closely, so what is being tested here? So we are ensuring every variable and it's used after being defined is not defined before it's used, and also check if data flows correctly across the statements. Clear? So you might have one question like, what would be the application of this? So this is to find bugs like uninitialized variables or wrong reuse or forgotten updates, something like this. Okay, that is what the application is. Next, we talk about loop testing. So a white box method focusing only on testing the loop behavior is this loop testing. So it is a white box testing technique that focuses exclusively on validity of the loop constructs. Okay. So now there are four different classes of loops. We have simple loops, that is single loop we say. Then nested loops, that is one loop inside the other. Next is concatenated loops, that is multiple loops in sequence. Then unstructured loops, that is badly written or spaghetti like logic. So let me mention here simple loop. Okay, that is single loop. Okay, see when I say single loop, like for while all this. Okay, the nested loop is one loop inside the other. Concatenated is multiple loops in sequence, right? Then unstructured loop is which are badly written. Okay, right. Let us try to understand one by one. First one is simple loops. Okay, basically the simple loops, this discusses the tester strategies for a single loop. Okay, if the test cases that are to apply is skip the loop entirely, that is zero iterations, or one pass, or two passes, or m passes where m less than n, or n minus 1 comma n plus 1 passes that test the near the limit. Okay, so now ultimately the objective is to ensure that the loop will work correctly in all edge and normal cases. That is simple loop. Nested loops. So nested loops, if we were to extend the test approach for these simple loops to nested loops, the number of possible tests would grow geometrically as the level of nesting increases. So this would result in an impractical number of tests. So Bezier suggests an approach that will help to reduce the number of tests. So basically, so nested loops are nothing but, this is a test for loops within the loops. Okay. That is too many combinations, further proceeding for exponential test cases. So then the Bezier's recommendations are what? So the Bezier's recommendation strategy is as follows. So we have to start from the innermost loop first, then set all the other loops to minimum iterations. That's what second point says. That is conduct simple loop test for the innermost loop while holding the outer loops at their minimum iteration parameter. So next point says that we have to test the inner loop first and then move upward loop by loop. Okay. So what does this do? By doing all this strategy, it reduces the total test cases while ensuring good coverage. That is about nested loop. Then we talk about concatenated loops. So concatenated loops can be tested using the approach defined for simple loop. So if each of the loop is independent of the other, however, if two loops are concatenated and the loop counter for loop 1 is used as the initial value of loop 2. Okay. Then the loops are not independent. So when the loops are not independent, the approach applied to nested loop is recommended. Clear? So like it is like two or more loops in sequence. So two or more loops in sequence means, let us say for I equal to 0, I less than 5, and I plus plus. Okay. For j equal to 0, j less than 3, j plus plus. Kind of. Okay. So what are the various cases for this particular concatenated loops? So the one is independent loop, next is a dependent loop. Independent loop is testing like simple loops. A dependent loop is as I mentioned earlier, I equal to 0, I less than 5, and I plus plus. Another for loop is j equal 0, j less than 3, and j plus plus. So j starts from I, like treat like the nested loops. Okay. So basically, use the nested loop strategy if values dependent on each other. That's what your concatenated loop says. Yeah. Right. Uh, oh, thank you, students.